30/24. Also here we have IP addressing, but here in the LAN A we have PC1, the source IP of the packets of the PC1 start with the 192.168.110, for example. This is the IP address of the PC1. After that, we have also one server. This is our server residing in the net B. This is the web server, and we need to send traffic or receive traffic from this web server, and the IP address of this web server is 192.168.210, for example. Okay, you know that when we need to see the content of the server, we need to create one HTTP request, give this request to the TCP, and finally give to IP. Finally, we have a packet contain the HTTP header. Let me write HTTP, then TCP, then source IP and destination IP. Source IP is 192.168.110, and destination IP is 192.168.210. And you know that the first thing that should be happen is the routing in the PC. Okay, how a PC can route the packet to the destination? You know about the process because I explained it before. Look at here, because destination IP, the destination IP's first three parts, 3 octets, are different with the source IP's 3 parts. Because of that, the PC can understand that this packet should be forwarded to the router 1 and should give to the router 1, because the router 1, you know, is the default gateway. Now router 1 needs to forward the traffic to the destination. How router 1 forward the traffic to destination? In router 1, as you will see in the future videos, we have a table. We call it routing table. You will learn about the detail of routing table. Don't worry about the detail. But in routing table, we have this information with some tools. We have this information 192.168.20/24 reachable from serial 10 interface. This is the name of the interface. You will learn about all of these features. This is serial 10 and this is serial 11. Each router has some interfaces, for example serial 10 or serial 11. And in routing table we have this information. If you want to reach to the 192.168.20/24, you should use the serial 10, and also if you want to reach to the 192.168.30/24, you need to send traffic from serial 11. That's it. As you can see, R1 with serial 10 can receive to the 192.168.20, and with the serial 11 it can receive to the 192.168.30/24. Because of that, when the R1 receives this packet, it can compare the destination IP with this table. In destination IP we have 192.168.210, and with compare with this routing table, it can find the destination interface or the outgoing interface is the serial 10. Because of that, the packet should forward it to R1, and finally R1 can give the information to the server. This is the routing in routers. Routers main function is the routing. Okay, as you saw, we have routing in PC1 for understanding that destination is residing in our network or destination is residing in another network. If the destination is residing in our networks, we can give the traffic, we can send the traffic directly to the destination. But if the destination is residing in another networks, we need to send the traffic to the gateway or default gateway or the router of our network. Then in router, okay, we can compare the destination IP of the packet we are receiving with the routing table and finding the destination or outgoing interface. Then we can forward the traffic. This is the function of the routing. This means that the IP protocol is responsible first for addressing the packets, and after that the routing. Okay, as you can see here. But don't worry about the detail, because we will understand many things about the routing in future videos. Routing is one of the major topics in this course and also in the other courses in the enterprise series courses of the Cisco for example courses. Very good. Let me to talk about now about the data link. You know that until now we created the packet, the HTTP header, and then TCP header added to the packet, or UDP header in some cases. After that we added IP. Okay, and now we have a packet. As I mentioned before, because we have different type of physical layer, we need to create or for example make ready the packet for a little different for the different type of physical layer. In physical layer we can have, for example, copper cable, fiber link, or fiber optic, or for example air. If you are using air, you need to make packet for sending on the air, or when you are using the physical link, we need to do something for making the packet ready for advertising or sending onto the physical layer of the copper. You will learn about all of these details in this course, but for now let me to say that the data link layer and physical layer are working closely with each other. Let me to give you one example. Assume that here in the link between R1 and R2, okay, we are using one wired links. For example, this is a copper cable and this is a wired link, and also here between the R2 and server we have wired. This is a for example Ethernet cable, the cables that you saw before. This is Ethernet, but here between the router and the destination, for example PC2, this is the PC2, we are using wireless communication. Assume that here we have one AP or access point, and or maybe this is the internal AP in the router, or this is the external AP, and the PC2 connected to the AP with the one access point. Maybe this is a server, another server 2 for example, and this is server 1. When you are sending the traffic to the server 1, the traffic can forward to the R1, and after that with routing the traffic should forward to the router 2, and then router 2 should give the traffic to the server 1, you know it. But when we are sending the traffic to the for example server 2, the source IP is 192.168.110, destination 192.168, for example 310, okay, assume that the IP address of destination is 310. The router 1 according to routing table can forward the packet to the router 3. Now the router 3 is receiving this packet, and the router 3 should forward the packet into the air. Here we have a different process, a little different process. Why? Because you know that we have some different rules for forwarding the data into the wired and also wireless networks. We have for example two data link layer protocols should make ready the packets for advertising into a special physical layer. For example, let me to give you one example here. When you are using the cable or copper cable, for example, one standards for cable is 100 base T, means the fast Ethernet. You need to use the Ethernet, okay, data link. This means with the protocol of Ethernet that you will learn about it in the next video, we are making ready the packet for forwarding into the copper cable. But when you are using air as the physical layer, assume that this is the air, okay, and we are using the air as a physical layer, we need to another standard, we call it for example 802.11 or Wi-Fi. Okay, this is Wi-Fi, another name, and most famous name is Wi-Fi. And here, as you can see, the data link layer is so related to the physical layer. According to the physical layer, which we should choose one data link layer, okay? And as you remember, in the original TCP-IP, we used, instead of two layer, only one layer in TCP-IP, and both of data link layer and physical layer we call them only link layer. Why? Because the physical layer and data link layer are related to each other. Because of that, if you are using, for example, 100 base T, the only choice is Ethernet. If you are using air, the only choice for data link layer is 802.11 or, for example, the Wi-Fi. Because of that, here we need to do another functions on the packet to forwarding the data onto different media. You will learn about all of these details, but for now let me to say that in data link layer we are doing some functions on the packet, and after that some functions we can forward the data into different media, and this is so important. In short, the TCP/IP physical and data link layer include two distinct functions respectively, okay? The functions related to the physical transmission of data, this is the function of the physical layer, plus the protocols and rules that control the use of physical media. The protocols and rules that control the use of the physical media is the function of the data link layer, and the function related to physical transmission of data, for example, include the voltage and current or some other frequencies are related to the physical layer. We will talk about them, but for now let me to give you one important notation about the Ethernet layer. You know that in each layer, for example in layer 5, in layer 4, in layer 3, we are adding only one header to the packet, to the data we are receiving. For example, HTTP added its packet to the data. Look at here, this is the HTTP header, and you know that here we have a message. After that, the TCP added its header, and now we have a segment. The IP added, or network layer added its header, now we have a packet. But in the data link layer, for reasons that you will learn about this reason in the future video, we are adding two header. The one header, we are adding one header and one trailer, means two things. The first is header and the second is trailer. Let me to show you. In for example, Ethernet. Look at here. This is the data. This is the packet we are receiving from the IP protocol or network layer. You know it. Now I'm going to add first one header. This is the header, Ethernet header. You will learn the content of this header in the next video, and also here we are adding one trailer. Because of that, only this is Ethernet header. Let me to write here Ethernet header, and also we have Ethernet trailer. This means that in all of the layers we are adding only one header, but in the data link layer we are adding one header and also one trailer. And the data link layer functions is making ready or creating the packet ready for the advertisement or forwarding in the physical layer. Okay, let me to review the topics that we learned about the TCP-IP in this video. You know that here we can see that packet, that the original data in each step now is encapsulating. Let me to show you. Look at here. This is our example. I'm going to write it again because the encapsulation is one of the important topics related to the TCP/IP. I will show you with some pictures, but for now let me write here. You know that when we had the for example our request for giving one web page, or we want to send the web page content to the client, we need to first create one request, okay, or one HTTP header. This is the HTTP header, and this is the first step. In the second step, the HTTP header, this is the layer 5 header. In the second step, as you saw, we added one header to this HTTP header, and that is the TCP header, or let me to say the transport header. This is the transport header. And also after that, this is, you know that this is the